very fortunate at a very last minute for Martin Liddell to kindly agree to step in and offer a presentation on. Oh, I spelt it wrong. I'm sorry. That should be a C, not an S. A presentation on RAAC. Martin is a regional director at SWECO. He's also the chair of the Structures RAAC study. He's been in the industry for over 35 years and has been involved in investigation and assessment of RAAC, mainly as shown there on the NHS, for around 15 years. He is a leading expert on this subject matter, and it is our pleasure that he has agreed at short notice to step in and offer his presentation. I can see he's at the forefront here. Hello, Martin. Thank you for joining us. At this stage, I would like to transfer controls over to you, Martin.
Okay. All right.
There we are.
Okay, so there we are. So why is RAAC such a problem? So I thought I'd just start with it because, you know, it is becoming to be quite a major problem nationally. It's been quite a lot of problem within for the NHS for sort of 2 or 3 years, and it's cost the NHS roughly so far about £500 million. We all saw the DFE problems that they had in the summer with the schools. They've got about 250 schools that are affected or have identified RAAC so far. They're expecting that to go up quite significantly, I think, as time goes on. The estimate of that for the DFE is about another £500 million just to deal with RAAC in the short term, the next year or so for them. Just to put it in context, the MOD think they've got 2,000 buildings-ish that may have RAAC in it, and I'm certainly aware of some water companies that have got thousands of buildings as well. So it is going on to be quite a problem. Michael, have you got control? Next slide.
Yeah, I've got the control here.
You have control. Excellent. So a little bit what I just thought I'd talk about, and I'm trying to keep this very brief. What is RAAC? Why was RAAC used when everyone seems to think it's a problem? A bit about the lifespan on RAAC, why it's become a risk, what guidance is out there, and then what measures can actually be taken if we've got RAAC. So that's what I want to talk about this evening. Yeah. So what is RAAC? So RAAC tend to be used where you'll come across it most often is you'll tend to see it in roof panels. It does exist elsewhere in other things. They tend to be about typically 600 millimeters wide. The length can vary from when it's first started being used. It might have about or as low as sort of typically 8 foot for those of you who are old enough, 2 foot spans. 2.4 meter spans. But as it went on and it was used certainly through into the 80s, you could get spans up to 5 meters or even more thicknesses. So what is RAAC? Well, it's reinforced aerated reinforced autoclave aerated concrete, but for you and me it's what Durox blocks are made from, so it looks very similar to Durox. There's a little photo of it on the left hand side there. So if you cut into it, it's very lightweight. It's got an awful lot of bubbles in it. It's got no fine aggregate. It was made from sand and lime with then an additive of aluminium powder to actually make it bubble and foam in its molds. And the thing what's unique about it, so AAC, foamed concrete, aerated concrete, is absolutely fine. So it's Durox blocks that are still used, thermalite blocks, aerated concrete. There's nothing wrong with that whatsoever. The only problems that came about with RAAC is, as the image is on the right hand side, when they made it into panels and started using it as panels in around the 60s and sort of mid 60s typically, through to perhaps largely the early 80s, still used later, but often the early 80s. It's when it was reinforced, and there's a section showing some reinforcement in there. It's the process of reinforcing it and using it as spanning panels that actually gave rise to the problems. Michael, do you want to move on? So why was it specified? Well, it was actually a really, really versatile material. It's comparatively lightweight material. If you throw it in the river, it will float. It's got a density of about 800 kgs a cubic meter, so it does float. Often it was used in roof panels. Often there's a rather dreadful image there that I've put there, but often it was used as flat roof panels. But going on to the next one, Michael, but it wasn't limited to that. It was used both in wall panels, quite often non-load bearing panels, in which case they often spanned horizontally, like this one here between, I think that one's steel frame, or it can be used vertically, and it can be used as a load bearing element in precast concrete buildings. So it was, and you'll also find it was used on pitched roofs going forward into the 80s, often onto a steel frame arrangement, but sometimes onto load bearing masonry. So it was a very, very versatile product. And also taking back into the 70s, pre-oil crisis and all the problems there, it's thermally, it's very efficient. So compared to where one was often building with solid building materials and solid walls, solid roof panels, its thermal performance was very, very good. So therefore it was widely marketed and quite widely used. The best estimate I've seen is there's 3 million panels of RAAC out in the built environment. Probably only about 500,000 of those have actually been seen and surveyed at the moment. So there's more out there that hasn't been looked at than has actually been seen so far. So it's still a problem that's going to go on for a long time. So I've put this one in here because you'll hear in the press that RAAC had a 30-year design life, and therefore because it was put in and it was 40 or 50 years ago, some people say, well, it's not a surprise it's failed, it's gone beyond it, or is failing, it's gone beyond its design life. But in the 60s, the concept of design life didn't really exist. It was brave new worlds for those people who worked or investigated buildings from that era. Buildings were built with very little cover. Buildings didn't really deteriorate. Concrete didn't really deteriorate in that way. So the design of the concept of RAAC having a design life that isn't really true, and it's something that the press have just picked up on. There is some basis for it, but they've picked up on it and exaggerated it a little bit. But fundamentally, if RAAC was well manufactured, well constructed, and well maintained, it will perform and last. But the problems come with RAAC where it's either been badly manufactured, which is probably the main issue, badly installed, less of an issue, but it is a bit of an issue, badly looked after, and in particular it can be subject to an awful lot of modifications. It gives rise to problems, or it's been subject to a lot of water ingress. So if it hasn't been maintained properly, it can give rise to problems, and some of those problems can be sudden failures at the bearing, shear failures, and so there can be sudden problems associated with RAAC. So next one, yeah. So why has it become a risk? I've put a little image in there of this. I mean, the photos of those panels are probably some of the worst ones, but that you'll see. But you'll certainly see panels if one looks at it. If it hasn't been painted for very long, you'll see an awful lot of cracking on it. You'll quite often see deflections in panels, and in particular differential deflection between panels, and it can have problems associated with the deflection and the cracking. That can give rise to problems. It's not as robust as normal weight concrete, so it can have problems from overloading. Water ingress, because it was used in a lot of roof panels, So water leaks can give problems. And what's quite interesting with RAAC is when it gets wet, it actually gets weaker. It gets about 20% weaker. It's a bit like mud in that regard. But also, so it does get weaker, which gives problems, but also that can initiate corrosion of the reinforcement. And then if you've got in buildings which have been relatively heavily serviced or being modified over the years, which is perhaps typically certainly a hospital environment, but even educational environments, you can get services penetrations cut through the roof. And it's quite alarming how uncontrolled holes have been cut in RAAC panels over the years, to really quite an alarming concern, really. And you can also have situations where panels were cut during the construction period, where panels were cut and weren't properly supported as part of that process, and to a certain extent that was allowed. But the primary concern around RAAC is regards to the anchorage of reinforcement at its bearings, and at the risk of getting a little bit technical, but I'm sure you guys won't mind at this time of an evening. The issue around, or the main issue around RAAC is with regard to the anchorage of the reinforcement at the bearings. Because there's very little bond strength between the reinforcement and the concrete, because the concrete's so weak, the way, and this was understood at the time of manufacture, but the way that the panel works is by having bars welded onto the end, transverse bars welded onto the end, and the left-hand image shows there's typically 2, might be 3 transverse bars at the end, but the very endmost one needs to be over the bearing. The problem the largest problem, and the one that gives the biggest anxiety over RAAC, is that panel, that end reinforcement, because it relies on good manufacturing controls and good construction controls, and we all know that the 70s are not renowned for either. So if the reinforcement is in front of the bearing face, you can end up where the main reinforcement isn't anchored properly, and that can give rise to a risk of shear failure, and the shear failure is a sudden failure that can give very little warning at the end of the day. And the other thing that compounds this is the brave new world that existed in the 60s or 70s. At the time, the specifications allowed for bearings as short as 45 millimeters on steel beams, and it didn't really allow try to encourage much longer bearings onto concrete beams. So you can have a 45 millimeter end bearing onto a beam, a design 45 mm end bearing. You have a bit of construction tolerance. The manufacturing tolerance has got to be that the transverse bar is over the bearing, and therefore it is quite easy for that transverse bar to be misplaced and for one not to have anchorage of the tension reinforcement. Go on to the next slide, Michael. All right. So again, I thought I'd just drop into this because it's technical. So the chart on the right-hand side is something that's come out of some research that's been done by Loughborough University, and what it shows is, as the transverse bar, if it starts in the green area where it's correctly positioned, you get a shear capacity. It reduces very slightly as the bar gets close to the edge, and then moving into the transitional zone 2, when it gets close to the bearing face. But as the bar starts moving in front of the bearing shelf, even by just 10 millimeters of scale along the bottom is, actually it's centimeters, sorry. So as it moves to 100 millimeters away from the end bearing, which is quite a lot actually, but you actually look at that and you go, well, the reduction in the shear capacity is I'll say only 50%. But which for shear capacity for those engineers amongst us is often not that critical. But what's very interesting about those figures is, so if reinforcement is misplaced, it's still got a high shear capacity. but it's at risk of a shear failure, and a shear failure is a brittle and sudden failure. And so what could happen is a panel that's got misplaced reinforcement could sit there perfectly happily for 40 years, but something happens to that panel. It gets overloaded, it gets a bit of thermal movement in a building, might have a bit of maintenance work being done on the roof, might get some corrosion of the reinforcement, there might be a water leak, something that happens to the panel, and this panel that has been absolutely fine then initiates a sudden shear failure. And that's the primary concern around RAAC, is that panels, what I said there, a 40-year-old panel that sat there perfectly happily for 40 years could still fail overnight. To put it into context, the Department for Education took the decision they did in the summer because they were aware of 3 panels that failed. Only 2, actually they were aware of 4 actually. 2 fell to the floor some years ago that initiated the problems. But they in their hunting for RAAC, they found 2 more where panels had failed but hadn't fallen to the floor because they'd got caught up on other things, ledges on the sides of beams, services, that sort of thing. So far, with all of the research that's been done and the awareness, that I think the current total of panels that have failed stands at about 7 out of 3 million. So, you know, I say this to not to avoid, you know, to put it into context. So a lot of this is a theoretical risk, but the reason it's become, you know, it became such an issue for the DFE is it's a brittle failure mechanism that will potentially give very little warning of failure. So surveying and monitoring buildings that are at risk of a short end bearing failure could not give the warning that one likes. And I normally liken it at this stage to the Only Fools and Horses chandelier sketch, where you could spend a lot of time staring at the wrong chandelier, and the one at the other end of the room is the one that fails. So I put that into context. But so what next one, Michael? So what guidance exists? There've been 2 excellent papers written by the Institution of Structural Engineers. I only say that is because I've had the delight of chairing the panel that's written those, but they are as comprehensive guidance as currently exists. The left-hand one was written 2 years ago now, just to sort of highlight some of the issues. But the right-hand paper, which was issued not quite a year ago, does give some guidance on assessment of the risk of RAAC. Michael, if we can go to the next one, makes sense. So this is something that's out of, oh, go back, yeah. This is an extract from the paper. So what's been done is the IStructE have set up a RAG rating, red, amber, green system of between so low risk, medium risk, and high risk, and then critical risk. It doesn't give you definitive guidance on how building owners should respond to that risk, because that's something more to a risk assessment that building owners need to take. There will be more papers coming out on that, but probably not for another 6 months or more. But the critical risk areas, which are where a lot of the schools were, you know, that we are really saying that needs urgent action. You know, and now whether urgent means shutting something down immediately like schools did, or whether it means just getting on with something very quickly, well, that's something that building owners need to assess. But then going down to low risk situations, it's suggesting just keep an eye on it and revisit it every few years. Currently, that guidance says every 3 years, but that's something that perhaps building owners will want to assess. In the next slide, Michael. And this is one that, forgive me, because I managed to delete my last one. I've only got half the table there. But the table that's missing from the top there that tells me or gives guidance on the end bearing lengths. So I recommend people, if you're looking into RAAC, in that guidance, it tells you how to deal with end bearings. And basically it says that if you've got an end bearing that's shorter than 75 millimeters, either because that's how it was installed or it's been cut or modified in some stage, well, that will consider as being a high risk scenario. And then there's other tables here which try to give a RAAC rating arrangement for other defects. So this is cracking or spalling or the deflections of the panels, and it gives that set of tables that one can follow. And if you look at those two tables, they're very similar, but the one on the left is if there's been no water ingress, i.e. no roof leak or surfaces penetration. So if a panel has stayed dry throughout its life. And the one on the right is if sorry, I got those the wrong way around. And the one on the left is if it has got wet, and you can see they all tend to sit at a higher risk. If it's got wet, it's either amber or red. And the table on the right is if a panel hasn't got wet at some stage, and the risk then varies from green if it's in good condition and good order, up to red if it's suffering from some problems associated with it. Next one, thank you. So remediation strategies. So what can be included? If you've just got short end bearings, you can widen the supports and put additional supports at the end bearings. But I have highlighted there that those end bearing extensions need to be effective. So you know, typically, although opinions do vary on this a little bit, if truth be told, between engineers working on this, but typically bolting some steel angles on and putting some mortar packing to give it a very positive support, or possibly, although I don't personally support this view, but possibly putting in timber supports to act as a positive catching method. Another option might be to put a positive support into the panels, which is basically putting in some members, often steel, could be timber, to provide positive support to the panels so that you've taken out the spanning capability of the panels so that there's no risk of failure. Or I might put in a passive support to provide a fail-safe so that it would catch the panel. Often in a lot of instances, that's a sort of timber grillage, timber joist, perhaps going underneath timber packers, could be a bit of steel. I don't think anyone's been brave enough yet just to put a net in underneath there, but it could be it's somewhere where you say, well, we're going to continue to use the space, but we'll make sure that it fails safe. Or of course, the next stage is to remove the RAAC, either just by taking the panels out or by replacing the entire roof, which would obviously get rid of the defect. The DFE, who are obviously doing an awful lot of work, have been implementing a range of these strategies depending on the conditions of the buildings, but they've announced, but whether they'll stick to it, but their end game is to remove all RAAC, but it might take them quite a while to get rid of that, and so they've been putting in measures as a range of some of those to keep the building safe in the interim. So that is a very, very quick flick through RAAC. I hope I've managed to. I've only got cameras on for a few people. I hope you're still all awake. If you're not, I do apologise at the moment. But does anyone? I'm happy to take any questions if anyone's got any questions on it.
Well, thank you very much, Martin, for that presentation, and to just explain what the issue is with RAAC and give an indication as to the areas of how it actually has failed, which is interesting, and the potential remedial measures, which, like everything else, it seems as if the remedial measures is complete removal and replacement, which is the better. Otherwise, I can see a whole load of goalposts being provided just to support mid spans of a system. But I would like to open up. We've got questions, and Chris, I can see you first. So, Chris, would you like to ask a question?
It was a very interesting talk. I've got a couple of questions, really. I guess a lot of these issues with school buildings and their lack of maintenance of roofs, and we're perhaps replacing felt roofing, which is allowed to water ingress. I mean, in terms of the structural surveys, do you check out the moisture content of these RAAC panels? And also, do you have some mechanism of finding out how the reinforcement sits by camera survey in terms of the bearings, to make an assessment of whether you need to take remediation works?
And it's very difficult. Testing with moisture content, typically RAAC doesn't respond well to moisture meters readings. It's very different to it's a very voided structure, so moisture meters tend not to work very well, and it is one of the problems. Often you're just left with visual identification, so to see if there's signs of water staining, which is it's not ideal, it's not easy, and particularly if something's been redecorated, they can often decorate out the panels. As far as looking at the end bearings, you've actually touched on one of the most difficult things to do with RAAC. If it's very easy to prove the negative, so if you have a very narrow beam, so schools, for instance, because they're quite small spaces, they often have fairly small steel beams supporting the panels. So you might have a steel beam with 100mm flange or even 150mm flange, and then it's very obvious to know that you've got a short end bearing. It's actually quite difficult to prove the positive, because you can have situations. So I was involved with a hospital which had 300mm wide concrete beams supporting the panels, but they had installed it with about 65mm end bearings. But the only way you can test is that there are radar companies out there who purport to be able to identify it with radar. The trials, well, not the trials, we've surveyed, us and other engineers have surveyed several thousand panels with radar, but it's very expensive. So typically for some of the hospital buildings, we perhaps spent, I think one hospital spent £300,000 surveying their panels. The accuracy, though, of the technique with radar, because of the nature of RAAC, the accuracy isn't very good. And so now there is some more research ongoing. So often it turns out the only way you can test your end bearings is just to go in there with a hammer and chisel and physically cut out the RAAC from underneath and physically expose it. And the problem with doing that is, one, you're damaging the panel when you do it. And the second one is often they have an Artex type coating, particularly when they're in schools where they're exposed. So you have an asbestos issue associated with it. So it's very difficult to prove that something's okay, and that's why schools are quite easy, because they typically had very short end bearings. So they managed to prove the negative, but proving the positive is much more difficult.
Okay, thank you.
Thank you. Another person with a question is Errol.
Hi, Martin. Yeah, it's great presentation. Thanks very much. Chris pretty much took my question completely. So yeah, the only other thing, I was just wondering whether or not they were mesh reinforced, so the sort of spacing of the reinforcement could be pretty much guaranteed, or whether they weren't effectively. I suppose that was the only other point to sort of query.
Yeah, the way the reinforcement was made is they were actually made up in welded cages, usually, nearly always. So they had some bars made to length at the bottom with the transverse bars on welded together, and then spacer bars, a few of those, perhaps only 4, 6 per panel, to space the top and bottom mat apart. They would appear to be the reinforcement would appear in that method where you could actually place the reinforcement quite accurately, but bearing in mind the 60s and 70s, they weren't very good at welding them. Often the end bars weren't welded right on the end of the transverse bars, and because they actually, the way they make, well, I don't know if anyone's ever seen, but the way they make Durox blocks or any of the blocks, and it's the same with RAAC, is they would just cast a massive cube of it. They bring it out of the mold just a few hours old while it's still very soft, and slice it up with wires. And that process of cutting could mean you could get quite a lot, in fact, a large variation on the cover to the RAAC. So yeah, in theory it looked like it could be well made, but in practice there could be a lot of variation in the manufacturing process.
Brilliant, thanks very much.
Okay, thank you for that. So this RAAC it's been around for a long time, and the understanding of the problem is not new. It was aware, but recently, because of these failures, it's brought its attention to us as industry now.
It actually, just seeing as this is an institution AGM, it is actually the work of the IStructE, because RAAC was known to be a problem in the 90s, and various research was done, largely being led by some work that the Building Research Establishment did for Essex County Council. It had a lot of schools, and it was known about. And you go back into the publications, and in the 90s there were a few, not very many, but publications saying be very, very careful with RAAC. It was then completely forgotten about until 2 panel failures were reported through SCOS, which is the Structures Confidential Reporting Methods, and in particular one of them. So it was in 2020 that a failure, which had actually occurred quite a long time before, I believe, I think the summer before, but it got reported to SCOS. Well, SCOS and CROSS as it was at the time. Well, SCOS as it was at the time, CROSS as it is now. But it was the work that the institution did to raise that actually then made it become nationally aware over it. So the institutions, well, you guys are obviously interested in your institution because you obviously come along to your AGM, but there's a lot of members, me included probably until recently, you sort of ignore your institutions and you pay your subs and you just think, what do we get for your money? But actually in the background they do some useful work. So I would just pat our institutions on the back for the way that they've responded and turned this into the thing that is now nationally aware.
So great job from the institutions of raising awareness, and in doing so raising standards. Financially, where does the money come from to rectify all of this work? Because 3 million and hospitals and schools are the buildings that have the least amount of capital funding to actually do the works that are required to be done. So where's all this money coming from?
Your big tax bill, Michael. It's fortunately your taxes are paying it all, so it's.
So
well,
I mean,
it's
like everything else, then, yeah. So government will obviously increase taxes in the foreseeable future to pay off the additional works, but I'm assuming there is going to be an absolute explosion of people running around saying that they can actually do RAAC assessments and validations, and the process for validating it, would that fall under building control, or would that go to the building safety regulator, because it is a unique issue of concern, of public concern? And how do we know and validate the competencies of the contractors who are going around fixing or doing this work?
Very, very good questions, Michael, actually, and these are points which I actually took up with the HSE and the building safety regulator just before Christmas, who are finally waking up. The answer to that is that no, I don't think there's an intent to deal with it in perhaps the same way that post Grenfell with cladding materials. It's an issue that I think the HSE is saying it's up to the building owners and the duty holders, as they would call it, to actually be aware. But for those of you who get involved, if you ever are unfortunate enough to get involved with RAAC, the guidance that we the IStructE have written gives you a very good way to classify the risk, but it doesn't allow you to start to assess the risk and to work out whether buildings stay open or not. So that's actually some work that someone, probably me, is going to have to take forward me as a chairman of the study group, to actually start trying to produce some guidance with it's probably going to come under the HSE rather than the Building Safety Regulator. But I don't think government is going to impose duties as it has following Grenfell. But there will be well, there are duties on building owners as duty holders to make sure that their buildings are safe.
And are there enough sufficient contractors to do this task who understand RAAC? I mean,
Well,
obviously you can't physically do it yourself, and you understand it really well.
I've had more than enough of it. So the purpose of the paper that was written by the IStructE, because they were very aware that the capabilities was held with a very small group of people. It was largely us at SWECO, some guys at WSP, and some guys at Mott McDonald's. Oh, actually, and Arabs. Actually, I shouldn't dismiss Arabs. They did a lot of work with the DFE, but there was a comparatively small number of firms who actually had the experience. The intent of the structures guide, well, not the intent, the what's been achieved with the structures guidance is any competent structural engineer, and I would say that's competent. It's got to be someone who understands remediation and assessment of building structures, but anyone who's involved in that sort of world should be able to take or will be able to take the guidance and can classify the risks associated with it. So the idea of it is to make sure there's a wide pool of engineers, and there is. There are a lot of contractors who will try and sell. Well, actually, someone earlier this afternoon called it snake potions. There's a lot of people out there who think they've got the panacea for this, and just be very, very careful over that. There's a lot of people trying to make money out of RAAC. So they need to be avoided or be treated with very carefully.
Okay, well that's yeah. So it's basically ambulance chasers who come onto the scene. Yeah, well, yeah. I mean, our association is fortunate that we do have members who are themselves structural engineers, and there's the opportunity for our members who work in the field of structural engineering to potentially have this as a means of ensuring safety and raising awareness and maintaining standards. So yeah, that's it. But I note what you say about be careful about information that's been passed out, and sadly governors in schools who do take a responsibility may well find that they will go down a path which may not be the best path for them.
Well, the DFE have recognised, well, it took a long time for them to recognise it, but the DFE have recognised that, and they now, so with a lot of schools and duty holders there, the individual schools, the governors do have to make decisions themselves, and I've been quite surprised, what they do expect governors to do. But here the DFE have very much taken the lead, and the DFE actually take control because they wanted a uniformity of approach, and of course they didn't want their children exposed to unnecessary risks or spending, well, I was about to say, or spending more money than they need to, but the DFE have taken quite a risk-averse approach with their response. But I would say to the DFE, they probably weren't left with much of an option, because the state of knowledge and understanding is still at very early days on it, and the DFE, you could understand the emotion that's around making sure our children are safe when they go to school. So that they were backed into quite a corner and had to take a risk-averse approach.
Okay, well, just one last one, and nothing to do with RAAC, but we had Ronan Point, we had high aluminum cement, we've got RAAC. Anything else that's likely to come in the next couple of years that we need to be aware of that could take the wheels off the car?
I've been
in our industry.
I've been doing a little work with some guys called the Manufacturing Technology Centre in Coventry, who are a sort of government-based research centre. There, if anyone knows it, there's a couple of huge buildings that have got 2,000 people, all of whom have PhDs. They have very wide doors to fit their heads in as they go in through the front, and they are getting involved with trying to assist and support the development of RAAC. In fact, I had a meeting with them this afternoon. they think this is going to be not the first, because we've had cladding materials, that they think our construction industry is online for quite a series of events. Wood wool slabs, you know, for those who get involved with it, you know, that's something that we've perhaps ignored, and who knows what the next one is.
Oh, well, watch this space. We'll let you know, and we'll be the first, and we'll hold it in our AGM. So, Martin, I really want to thank you for stepping in at last minute. For those who don't realise, we had it all arranged and prepared, and just after Christmas, literally just after Christmas, an email came to say we can't do the presentation. It's like, great, thank you for that. And yeah, that's my wobble, and then I had to reach out, and Martin came to the charge, and thank you so much for that. I appreciate it.
It's the trouble with knowing you, Michael, but it's been my pleasure.
It has been a pleasure listening. I'm conscious of the time. The technical presentation is finished. I just open it up for any other comments that you'd like to raise to us as a committee. I got 5 minutes. I mean, I'd like to, Rosemary, I'm right in saying that 2-hour CPDs will be recorded on everyone's record, so we don't have to upload our CPD records. And as you all know, this year, the CPD record will be from January to December, and our mandatory CPD hours is 35 hours. So please, if you know, we as a region will do our best to supply the CPD that is relevant and efficient, and where you need to do top ups, please top up on your CPD records. If there are no other comments, I'm happy to close 5 minutes early. Thank you all for attending. I appreciate your support. I look forward to seeing you at any of our regional events. Have a good evening, and if you're traveling home, have a safe journey home. Thank you. Bye.